Welcome back to this series of videos on data engineering. In this video, we're going to create a machine learning pipeline using Azure Machine Learning Studio. Azure Machine Learning Studio is a machine learning platform as a service that Azure provides where you can build machine learning pipeline and deploy it both uh, in a coding form. That means you can host a Jupyter notebook and code a machine learning pipeline, or even you can use a no code platform hosted inside Azure. The advantage is that the Azure Machine Learning Studio can seamlessly connect with the data lake and can take data from there and use that data for the pipeline, and the deployment of the pipeline can also be done from inside the Azure Machine Learning Studio. So let us see how this is done. So in the first video, we are going to use an inbuilt dataset that is there in the Azure data store, already there in the Azure data store, and we'll use that to build a machine learning pipeline. In a subsequent video, we are going to see how we can upload a data set from an external source or connect to a data lake where some external data can be there. And from there, we can use the data to create a machine learning pipeline. So let's search for Machine Learning Studio. So this is Azure Machine Learning Studio. If you don't have it, if you have not recently used it, you may have to search it from here. Just search for Machine Learning Studio, Machine Learning, and that's how you'll get it. Go over there, create a new workspace. As usual, we'll create a new resource group where all our resources for this will be stored. We'll give it a name. We'll post it in a data center that is nearest to the users, in this case us. You can see here that automatically Azure will create a storage account. If we want, we can create a new storage account, but in this case that is not required. We'll use the same storage account that Azure is creating on its own. Then there's something called Key Vault, Application Insight, etc. We can ignore this and keep it as default. We'll leave it as public. We don't need to encrypt the data for this purpose. Credentials can be left as is. Tags we don't need to give. Review and create. Let's pass the validation. Create Azure Machine Learning Studio. Setting up the Machine Learning Studio, as you can see that it has to create quite a few services to create the Machine Learning Studio. Machine Learning Studio has been created. And launch the studio, which is essentially a web-based service. It's loading the studio for us. Sometimes it takes a little bit of time because we are using a student account and the allocation of servers for a student account is not always efficient. And that's why you'll see a little bit of some cases latency in opening the studio. It also depends on the internet connection. The internet connection is slightly slow, it may take a little more time than normal. Let's wait for the machine learning studio to get launched. Just pause the video for a moment and we'll be back once it is launched. Okay, the machine learning studio has now been launched. Now, before we start building the pipeline, the first thing that we need to do is to create a compute instance because the machine learning pipeline need a compute instance to run. So we will go to the left. And so this is the panel which has all the services that Azure ML Studio provides, which is enterprise grade services. So this is meant for working on very large enterprise data sets, which is very, very important and is different compared to typically when you do it in an academic environment where the data set may not be that very that huge. So here you will go to the compute and we'll create a compute instance. As you can see, there are other options available. For example, you create a compute cluster if the data set is extremely large or the model is extremely complex. You can also have Kubernetes cluster, which has the facility of Docker containers and serverless, and you can even attach external computes to this environment. Okay, so we will create a new compute environment, give a compute name. So we are creating an instance, which is a basic compute, one instance of compute, which is good enough for our purpose. So give a name. We will use a CPU. Now here you see there are various CPUs that are available. Now usually a more experienced data engineer will be able to figure out that which type of CPU is most relevant for the kind of work that you are doing. In our case, we'll just select the standard one. This one says that after how many times or how many minutes of idle time, the CPU will stop. So what happens is that if you have uh, significant idle time, the CPU will automatically stop to ensure that you don't consume dollars for running a CPU which is not working, which is idle. So here it is saying shut down after 60 minutes. We'll leave it as that. All other things that you can keep it default. Yes. It is creating the compute instance. Take some time to create the compute instance. Once the compute instance is active, this becomes usable. So let's wait for some time while the compute instance is created. Taking some time to create the compute instance. It's about to get created because you can see here, yeah, and it has got created. You see it's will get updated very soon, and you see it's running. So you see here, you can host a Jupyter notebook here, and this Jupyter notebook you can connect to all the resources of Azure. So unlike a normal Jupyter notebook, which is on your desktop, this Jupyter notebook is hosted on the Azure platform, and hence all the resources that you need from Azure can be connected to this Jupyter notebook very easily. So in case you need to build a machine learning pipeline on the Jupyter notebook and need to access the data from the data lake, you can do it on here. But in this exercise, we are not going to do that. In this exercise, we are going to create a no-code machine learning platform. And for that, we will get to this designer. This designer allows you to create a no-code machine learning platform. Many times, no-code machine learning platforms are useful, especially for a business user. It is very easy to understand, and for prototyping, for rapid prototyping, is also can be of great use. So there are some templates already provided, but we'll create it from blank and we'll use an inbuilt dataset. So this is the canvas where we build the machine learning pipeline. Now, if you see, there are two tabs. One is the data tab, the other is the component tab. The data tab is the tab where you would attach any external data to this so that you are able to access the data and use it in the machine learning pipeline. We will see that in one of the subsequent videos. In this video, we are going to use one of the sample data, which is the adult census income binary classification. So these are classification problem where certain attributes of population like age, working class, education, etc. is given, and we need to predict whether a particular person having these features, whether their income is less than equal to $50,000 or more than $50,000. So it's a very simple binary classification problem. Now, in this whole exercise, our objective is not to build a very good or a very advanced model. The whole idea is to see how we can use Machine Learning Studio to create a machine learning pipeline. So we'll keep the model simple and the pipeline simple. We'll not do all the pre-processing steps that are usually done when you are building a very robust model. Because we want to see how the model is created rather than trying to make a very good model. So let us first name this. We'll call this income prediction. The description as income prediction. And it's a very drag and drop interface. So we'll just drag this data set over here. Now, if you right click on this node over here, you will be able to preview the data. So this is the data. see age, working class, FNL weight, which is some information, not sure what it is. But anyway, it's a feature. Education, number of years of education, marital status, occupation, relationship, race, sex, capital gain, capital loss, hours of working per week, native country, and finally you see the income. So income is our target or label, and you can see the income is classified as less than equal to 50K or greater than 50K. So, and you see the distribution. So some basic statistics are also there. For example, if you go to hours per week, and if you go to the right hand side, it will give you a histogram of the number of hours per week, the number of people for observations falling under certain range of number of hours per week. So usually this kind of charts, if you have to do it in through coding, you have to write specific codes and call specific packages for this, but some of these are automatically available over here. So this is how the data set looks like, and what we first need to do, so there are various pre-processing, so it's a classification problem. So we can use classification models like logistic regression, decision tree, support vector machine, and those of you who are comfortable in machine learning know that which model works better under which circumstances. So I am not going to get into those details in this particular video. Also, we know that before we uh, use this data for the purpose of training a model, we need to do multiple pre-processing. For example, first we need to find out the missing values. Then probably you'd like to see if there are any outliers. You will like to see if there is any class imbalance. Class imbalance is not there much because we have seen in the preview of the data that the distribution of uh, more than 50K and less than 50K is kind of, there is some degree of balance. Though they are not equal, there is significant number of observations which are greater than 50K. So probably not much of class imbalance in this particular case. However, there can be outliers. There can be some attributes that are having high cardinality. There can be attributes that are having collinearity. So all this kind of pre-processing typically you do before you can actually train a model into a data set. Because our objective is not really to build a very robust model, we will skip all of this except one step, which is uh, treating the missing value. So that's the only step that we are going to do. Otherwise, we'll directly take the data into training. So in order to process the missing values, we need to know which of these data, which of these features do have missing values. Now for that, we need to get a summary of the data, and for that, you can use a node. So each of these nodes essentially, or components essentially, are packages, inbuilt packages, just like packages in Python or R, they're packages. Only difference is that these packages can be configured. Okay, instead of coding, it can be configured, and they're productized. Okay, so you can have parameters configured against these packages. Okay, so we'll look at package called summarize data, and if you have to summarize the data from this data set, all that I have to do is to hold your left key of the mouse and drag and drop the data into this. Okay, so this will connect it, and then this will summarize the data. Now then, how do we execute? Now this is where the process is slightly different. Normally what happens when you have an integrated development environment like a Python or an R, you can directly run it from there, from the IDE. But here, because this is for Azure Machine Learning Studio, the objective is to handle very large data sets. The way it handles it, it creates jobs. So while this pipeline remains as a draft pipeline, every time you want to run the pipeline, you need to create a separate or submit a separate job. And against a pipeline, there can be multiple jobs. Combination of these jobs are called experiments. So I can combine multiple jobs into one experiment. If there's a major change in the pipeline, let's say I want to change a specific model, then I may create a new experiment. And usually you will have multiple iterations involved to figure out that which type of models are working best, or if you're doing some hyperparameter tuning, which set of hyperparameters will work the best. So if we, for example, want to just summarize the data, all that I need to do is first save this and then just say configure and submit. When I say configure and submit, what is going to do, it is going to submit a job for me. So let us do that, configure and submit. And so as I said that a set of jobs are clubbed together. Experiment is the first job I'm creating. There is no previous experiment to this, so I should create a new experiment. So let me call this income prediction experiment. Call this experiment 1. Experiment 1. And you can just say display name as okay. So we'll go to next. And here is where you have to attach an instance to this experiment so that the job can run. Remember, the job will require a compute environment to run. So this is where you require an instance. So by default is a cluster. We don't have a cluster here. We have not created the cluster because the data set is not that large. So instead of a cluster, we'll select an instance. And moment you select an instance, if your instance is running, you'll see the instance over here. That is the reason we first created the instance. And here you see the workspace blob store. So when the job is running, it is taking the data into from, let's say, a data lake to a blob store, and which is the data store, and it will use the data stores, okay, for running the machine learning model. There's a difference between a data store and a data lake, because in a data store, the data can be in a structured format, and whereas the data lake we know is in the blob format. Okay, so that's why we need to have our data stored for running the machine learning pipeline. Because this is an inbuilt data set, we already have this inbuilt data set available in the blob store. So we'll leave it as the default blob store, then we'll submit. You'll see the job is getting submitted. Now, all of these pipelines or all of these features are meant for handling very large data sets. So that's why you will see that in normal circumstances, what takes us very small amount of time, it will take a very large, significantly larger amount of time. And that is by design, because the way the architecture is designed, it is used to handle very large data set. And hence, same architecture applies for small data set as well. And hence, it is taking a longer time than probably what it will take if you run the same code on a Jupyter notebook or a Colab notebook. So now if you go to the jobs, you will see that there's a new experiment that is created. Okay. And under the experiment, you have a job. So there can be multiple jobs under one experiment. And right now we have only one job. You can see the job over here. So again, one job can have child jobs when you're running a huge number of jobs, especially when you're using something called AutoML. AutoML is used when you have to do a lot of hyperparameter tuning, and it is not possible to manually do all the hyperparameter tuning and arrive at the most optimum result. So in those cases, something called AutoML is used. So in those cases, there will be many child jobs against one job. So the entire environment is built for production grade, very large processing of very large data. So if you go to this income prediction, you will see the pipeline, and this pipeline is running. This is a very small pipeline, and you have seen this has become green, which means that the run is completed. When we complete the pipeline, we'll see that there are four major colors. The first one is the hash gray. Hash gray means the pipeline is, or the particular job is yet to be in queue. is waiting to be put in queue. Then hash blue, which means the job has been put in queue. Then hash green, which means the job is running. And solid green, as you see over here, means that the job has been completed. So in this case, the job has been completed, and we can now see our objective was that we want to see which are the data that has missing values. So So here you see that it has given me a summary of statistics, and one of the important things is this missing value count. And we can see three features: working class, occupation, and native country. Working class, occupation, and native country. These three have missing values. Now, as we all know, there are different treatment methods for missing values. We can impute if any numeric value with a median value or any categorical value with a modal value. However, the first choice always is to remove any row containing missing value if the number of rows that we are removing is not very high. So here we can see there are 32,561 rows, and if there are around 1800 missing values, that's not a very large number. Even if I remove 1800 rows from 32,561, we'll have enough sample to build the model. So in this particular case, we are going to remove the rows, okay, for missing value. Now, we have to go back to our draft pipelines. So remember that this is a job that has been executed. So no change can be possible in this. So that's why you have a draft pipeline, which is lying over here. This is the draft pipeline, and whatever changes that needs to be done, or whatever additions that we need to do. For example, now we need to create the complete pipeline. You need to work on this draft. One disadvantage is that every time you make a change, you have to, it's not like a Jupyter notebook or Colab notebook where you can just continue running uh, any additional changes that you have made. If there's no concept of a job and a draft there. But here, because it's handling large data set, you have a separate draft where the mother copy of the pipeline is stored. And as and when you want to run it, you have to run it as a job. Once the job is executed, you cannot make any change to that particular job. So now that we have to build the rest of the pipeline, we have to work on this particular draft and build the pipeline fully. It is slightly time consuming if you have to submit the job for every step of the pipeline. So instead, what we'll do, we'll build the entire pipeline and then we'll submit the job all at once. Okay. And we'll do that in our next video.